Okay, so today we're going to finish up our unit on probability by looking at counting methods. We're going to start by looking at what's called the fundamental counting principle, but more so we're going to be looking at permutations and combinations because those are going to be used in subsequent sections. So really what we're looking at here, counting methods, they're going to reveal how many ways a particular event can occur. And in some ways, the formulas we've been using for probability, okay, we have a fraction and the bottom number, the denominator is the total. This is really another way of getting at that total from more complicated procedures. But this is that fundamental counting principle. It says that if a procedure has two steps in it, and the first step there's m possibilities, and in the second step there's n possibilities, then for the overall procedure, we multiply m times n to get the total number of results. And in some ways, this is really the multiplication rule all over again. The multiplication rule says if I have a multi-step procedure and I'm looking for probability, I can break it into the individual steps, calculate the probability one by one, and multiply them together. This is doing the same thing, but only looking at the totals. It says what's the total for step one, what's the total for step two, and then multiply them. So a couple quick examples. Flip a quarter and then roll a die. How many results? Two-step process. Flip a quarter. Two things can happen. Roll a die. Six things can happen. So overall, I would multiply them. 2 times 6. 12 different possibilities. And certainly that's one where I could write the entire sample space down and I would confirm there are 12 possibilities. Flip 3/4. So a three-step procedure. Flip the first, flip the second, flip the third. Each of them in turn, each flip of the quarter, there's two possibilities that can happen. So overall, 2 times 2 times 2, 8 possibilities. And again, I could go through and write down the sample space for flipping 3/4, and I would see there are 8 possibilities there. There's one more. We're designing a menu for a restaurant. We have 4 appetizers, 6 entrees, and 2 desserts on the menu. How many different meals are possible if we consider a meal consisting of one of each of those things? Okay, 3-step process. Pick an app, pick an entree, pick a dessert. Multiply them together. 4 times 6 times 2. There's 48 different possibilities to create a meal at this restaurant. Now, more so, as I said, we're looking at something called permutations and combinations. And you may have encountered these in past courses. Again, it's looking at an experiment and asking how many ways can I accomplish this? But it's a very specific situation. I'm starting with a group of objects. I'm going to take some of them without replacement. I want to know how many possibilities there are. Now, both of those situations lead to what are called permutations and combinations. There's a critical difference between the two. So certainly you'll want to know how to calculate them, which we'll get to in a second. But even more so, you'll want to know that critical difference between the two. What tells you it's a permutation and what tells you it's a combination. This is the difference. It comes down to the selection order. I'm starting with a group of objects. I'm taking some of them. The question is, do I care the order in which I choose them? If the order is important, if it says it in the problem that we care about the order, or when I select them, they're getting different things, or am I treating them differently, that's a permutation. But if the order doesn't matter, or if when we select them, we're doing the same things with them, that's a combination. In particular, the lottery, how many different possibilities are there for the lottery? That's always going to be a combination problem because we're only matching the numbers. We don't actually care the order they come out. So 2 quick examples determining if it's a permutation or a combination. 10 students are in a science fair. We're going to give the top 3 students $100 scholarships. So I'm starting with 10 people. I'm choosing 3 of them, and I'm going to give those 3 people $100 scholarships. That's a combination problem. They're getting the exact same thing. It doesn't matter who got picked first, second, or third because they're all being treated the same. If the problem had said, okay, 10 students at our science fair, and we're going to assign them first place, second place, and third place awards, that's a permutation problem because I'm treating them differently. They're getting different awards. 15 players are on a team. We want to know how many starting lineups of 5 are possible if we specify the position they're playing. That's a permutation because we're assigning them specific positions in that starting lineup. Want to read the problem carefully and decide if order is important. Are we treating them differently? Are they getting different things? That's a permutation. So the formula for permutations and combinations are going to use this thing called a factorial. And some of the formulas in the next section, you'll see this factorial come up as well. If you haven't seen it before in mathematics, all it means is a repeated multiplication. It's a decreasing multiplication. I start with the number next to the factorial, and I multiply times at every whole number that's less than it. So 2 factorial is 2 times 1. 3 factorial, 3 times 2 times 1. 4 factorial, 4, 3, 2, 1. 8 factorial, 8, 7, 6, 5, 4, 3, 2, 1. Technically, 0 factorial is going to be equal to 1. It's a definition. These are our formulas for permutations and combinations. Now keep in mind, the calculator doesn't really have a lot of built-in functions for this particular unit as we had on the last unit, and certainly going forward we're going to see a lot more calculator functions, but this is where it's going to be helpful in this unit. Permutations and combinations are definitely built into the calculator and the app, so certainly watch the calculator video. But if you're curious and want to practice it and see exactly how the formula is working behind the scenes, this is what's happening. I mean, you might want to, when you're working on the homework, try one of the formulas out. Again, see if it matches the calculator. NPR, it's going to be a fraction, n factorial over n minus r factorial. And CR, n factorial over n minus r factorial, r factorial. And even though the formulas are fractions, what's always going to happen is when you actually calculate it, everything cancels out and you're left with a whole number. And you'll see that in the examples in a moment. And the n and the r, n is how many things you start with, r is how many you're choosing. And that'll be clear in the problem. If they're not the exact same value, n is always the bigger number. So let's look at 2 problems. Club has 8 members. We're electing officers, president, vice president, treasurer, historian. How many ways can this be done? This is definitely a permutation problem. I'm starting with 8 people. I'm picking 4 of them out. The critical thing is making that decision about, is order important? They're getting different positions. So this is a permutation problem. It's going to be 8p4. I can definitely use the calculator for it. Again, permutations and combinations, when you watch the video, you'll see it's under the math menu. But let's see how the formula works. 8p4, if we use that formula we saw, it's going to be 8 factorial over 8 minus 4 factorial, which is 8 factorial over 4 factorial. Now keep in mind, when we simplify that, we can't do any canceling until we write out the definition. 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. 4 factorial, 4, 3, 2, 1. But notice, most of it's going to cancel out. That's always going to happen. I write out all the factorials, I cancel as much as possible, I multiply what's left. 8 times 7 times 6 times 5, 1,680 choices. Again, this is definitely not one I'd want to write out every possibility. Again, 8p4, if I put it into the calculator, a couple seconds, the 1680 is going to come out pretty quickly. 8 students are in a club, 3 of them go see the Capitol. N is 8, R is 3. The 3 people are getting exactly the same thing. They're not being treated differently. This is a combination. It's 8C3. Again, if I want to use the calculator, it's under the math menu, or I can use the formula. 8C3, 8 factorial, 8 minus 3 factorial, 3 factorial. I write everything out. 8 factorial, 8, 7, 6, 5, 4, 3, 2, 1. 5 factorial, 5, 4, 3, 2, 1. 3 factorial, 3, 2, 1. I do my canceling. I cancel as much as I can, so certainly the 5, 4, 3, 2, 1, top and bottom cancel out immediately. I'm left with 8, 7, 6 over 3, 2, 1. I certainly can cancel a little bit more. The 3 and the 2 cancel nicely into the 6. I'm left with 8 times 7, 56. Again, try out the homework. If you have any trouble with this section or any of the earlier sections, post on the discussion board, come to virtual office hours, go to the ASC virtual sessions. We're here to help you.